Hello, today I want to make a little video about how you can use an oscilloscope to estimate the capacitance of a capacitor. And why would you want to do this? First question. Sometimes you can't get a good measurement on the capacitance of a capacitor with a multimeter. And usually when it comes to that, you have to use an oscilloscope, especially for smaller ones when we're talking like picofarads. You have to use an oscilloscope to kind of estimate what the capacitance is. And I just wanted to show a quick method of how you can do that. One thing to note, the kind of logic behind this is that when you have a small RC circuit like this right here, we've got a signal. In this case, we're using a square wave signal. Then you've got a resistor and the capacitor. There's what's called decaying transient. So when the voltage from our square wave goes up, it takes a little bit of time for the capacitor to charge up to that full square wave voltage. And also when it goes down, it takes, again, sometimes to discharge to that voltage. And when we look at this on an oscilloscope, we can kind of estimate how much time or what frequency, that square wave needs to be to just basically match that full charge and full discharge. And when we match that, find that frequency that it takes to fully charge it up and fully discharge it, we can then kind of go backwards and figure out the capacitance if we have a known resistor. And the reason we can do that is because we know that the time constant, which is our resistor value multiplied by our capacitor, is roughly equivalent. Five times the time constant is roughly equivalent to the time it takes to fully charge that capacitor. And when I say roughly equivalent, at that time, the decaying transient is only roughly 0.007 of its original value. So at this point, we can just say it's negligible. So what we do is, again, with the oscilloscope, we try to find that 5 tau. 5 times the decaying transient, that point, and figure out how many milliseconds it takes. Now here, what we're going to do is we're going to use a 10 microfarad capacitor, dielectric capacitor, and try to approximate that. And right here, I've got a little frequency generator, signal generator. We're using the square wave from it. If you want to just look at the square wave part, I can hook my oscilloscope up to that. Take out the capacitor and just look at that real quick. Yeah, it's not a perfect square wave, but good enough. Again, this is probably going to affect the accuracy of it because this is a cheap little thing I bought for 600 yen off the internet. Like $4. And so that will affect our accuracy. The fact that the square wave itself is not too accurate, just bear that in mind. But you see here, when I plug in the capacitor, I don't want to measure here on the resistor. I want to measure right here I want to measure the voltage across the capacitor. So we're going to connect our probe to the this side above the ground. And see, I've already got it kind of tuned because I was practicing, obviously. But let's just untune it real quick. And you see here, it actually looks like it's a almost critically dampened system right now, but I get the frequency up a little bit more, so it stops shifting. You see here, it's at this point at 4.3 hertz, it's completely charging. So this is more than 5 tau. So let's just drop it down, or increase the frequency a little bit more, a little bit more. Now we're getting closer to 5 tau. And when we get closer to 5 tau, we should start seeing the voltages should not get up to their peaks. So we can see that there's a little bit of a drop in the peak voltages. Still not dropping really. We're almost there. A little bit too much. And again, this is kind of like, I'm still practicing this, but it's kind of an about thing that you do. So now we're at 8.14 hertz, and you see here, it tells me what the width is of this little part right here, and I'm going to use that, which is 59 milliseconds. Grab our handy dandy TI-89, Here, what we're going to do is we're basically doing this. We have our time is equal to 5 times RC. So to get this C, we're going to divide the time by 5 times R. And that's going to give us our C, roughly. So here, let's put in, what do we have at 59.26 milliseconds? So 59.3 to the negative third times 5. And because we want microfarads, we're going to multiply by 10 to the 6th. And we got our capacitance, or resistor. I'm not actually measuring it. It's probably not 1,000. Just bear that in mind. This is not an accurate resistor. So again, this is just an estimate, everything. But you see here, we get 11.86, which is pretty good considering it's a 10 microfarad capacitor, which is pretty cool. That you can do this with an oscilloscope just to get a rough estimate of what the capacitance is with a known resistor and some cheap frequency generator. And again, a cheap oscilloscope. This was like 6,000 yen, so maybe 40 bucks in the US. It's a Finny DSO153. I'm not being paid by them. But this thing is, I'm very proud of, happy with it. It works great, and you can do stuff like this. Trying to, my multimeter doesn't measure picofarads at all, so I'm gonna use this to try to get a rough estimate for some tuning stuff, making like radios and all that. But anyway, if any of you wanted to try this out, go ahead and give it a shot. Thanks for watching.